This simulation shows how Spanning Tree Protocol, STP, prevents switching loops while maintaining redundancy in a switched network. In a network that requires high availability, administrators often configure switches in a redundant topology, ensuring that if one path to a destination is broken, another path can be used. For example, if computer 1 wants to communicate with server 1, the frame takes the path from switch 1 to switch 2, and finally to switch 4, where it is delivered to server 1. The reply from server 1 takes the same path back to computer 1. However, if the link between switch 2 and switch 4 is broken, the frame can take the path from switch 1 to switch 3 to switch 4. There are two problems that must be resolved in this scenario. The first is to prevent a switching loop when all the links are up, and the second is that the switches must have some way of knowing when one of the links is down. Let's look at the first problem. Remember that switches forward broadcasts to all connected ports, so that if computer 1 sends a broadcast frame such as an ARP, switch 1 forwards the frame to both switch 2 and switch 3. Switches 2 and 3 in turn forward the broadcast to switch 4. Switch 4 forwards the broadcast to server 1 and to switch 2 and 3. Switches 2 and 3 forward the broadcast down to switch 1, and the cycle is repeated. The only way to stop the cycle is to physically break the loop. Unfortunately, manually breaking the loop by disconnecting a cable eliminates the redundancy. This is where Spanning Tree Protocol comes in. STP is a protocol used between switches to ensure that no loop is created in a redundant topology. STP also has the ability to detect when a link is broken so that an alternate path can be used. Here's how it works. When switches are connected together, they don't immediately begin forwarding frames. Instead, the switch ports are put into a blocking mode that only allows the transmission of STP frames. The goal of STP is to create a loop-free topology. The exchange of STP frames is used to determine if a loop exists, and if so, one or more switch ports stay in the blocking mode in order to prevent the loop, while the other switch ports begin forwarding frames normally. In this case, one of switch 4's ports remains blocked. Now, if computer 1 sends a broadcast, it is forwarded as usual until it gets to the blocked port on switch 4, where it is discarded and no loop occurs. Redundancy is maintained because STP frames are still being periodically transmitted. If a link is broken, STP detects this and the blocked port begins forwarding frames again. Now, communication between computer 1 and server 1 will go from switch 1 to switch 3 to switch 4, bypassing the broken link. STP is a complex protocol, and this simulation left out many of the details. But as you can see, STP is a requirement if you want redundancy in your switch network.